Mom. We're in it together. We're on the same team.
Sure. Okay. Yeah, it's dinner time somewhere, isn't it? We'll rope back Wayne. Here he comes. He hears us. He's getting ready to enable his microphone.
I'm on.
Awesome.
All right. Let's begin our webinar. Good afternoon, everybody. Welcome to the webinar. My name is Ken Gracie, and I have on board from Parallax Kate Hay, who is a co-host with me, and Stephanie Lindsay, who is our flight controller, and she helps manage questions, technical problems, and just makes it go right. We'd be lost without her. Thanks, Stephanie. Before we talk about our special panelists today, we'll set the background for the webinar. So today we're speaking with middle school educators, and we're going to be asking them a few questions about how they relate robotics to some of the newer teaching initiatives like project-based learning, computational thinking, cross-curricular learning, STEAM, etc., because there's such a long list of these words. You know, at Parallax, we're often stuck in the office, and we do that really well, but we serve education, and so these are important things for us to hear and to hear what is interesting to you. So we hope there's a lot of sharing around the topic. So first we'll discuss that, and then second we'll be asking our teachers to share some of their tips with others. And this video is being streamed live to Facebook and will also be recorded for Parallax's YouTube channel in case you want to share it with any of your friends. So before we really jump into it and meet the panelists, I'd like to tell you how to interact with the webinar, and this can be very tricky if it's new to you. So this tool, which is Zoom, has 3 ways you can ask questions. You will see a control panel, and on it there's a Q&A. You can press that and ask a question, or you can use the chat window and just go ahead and type in what you want on chat, and then others will see it flowing in, so we know that works. And then under the participants window, you can raise your hand, and then we can enable your mic and also your video if you want it. So we can allow you to talk. This is for you to participate, so feel free. And that's all of our housekeeping. So let's jump right in and meet some of our superstars. These are some very humble people that I want to introduce you to, but we're very proud of what they're accomplishing for their students. And the first one I'll introduce is Theresa Burke, and she teaches English, History Core, Technology at Lichen K through 8. But I'll let her tell you a little bit about what she does because it's very interesting. Teresa?
Hi, so I teach English. That's my primary task, and we have a block of course structure, so I blend the history and English together. Last year I actually taught 2 additional periods. One was project-based learning and the other was, I don't remember what they called it. Something unusual, but this year we've narrowed our periods down, so I have basically lost my project-based learning period. So I take that as a challenge to build all of that into everything else that we do. And I teach at a preschool to 8th grade school, about 700 students in a neighborhood. And I've been here 3 years. This will be my 4th year. I previously taught at a K-5 school, and that's where my interest in robotics and being able to give access to the students to an understanding of robotics and the future of robotics in our culture, that's where that was really ignited. And I just sort of took that here into 7th grade, which is wonderful because there's so much more I can do with 7th graders than the 5th graders. Even though everything I do still has to be fundamentally literacy based. So that's the focus of my work, regardless of whether I'm in our makerspace, whether I'm teaching grammar, whether I'm teaching comprehension, or whether we're running our scribblers for some activity in class.
And Teresa, it has to be noted that you have obtained a $10,000 grant from Infosys Foundation to make a makerspace at Lichen.
That's correct. So surprisingly enough, my first year here, I received an email just inviting teachers to have students submit projects. And so I threw it out to the classroom, never expecting anything to come back. And I had one student who just latched onto that. And he's like, Miss Burke, we're going to do this. I'm like, okay, we're going to do this. And he prepared his project with some procrastination and some stumbling blocks along the way, and we got it submitted about 15 minutes before the deadline, uploaded online, and then we didn't hear from anybody. He simply made a solar-powered boat out of recycled materials, and we just didn't hear back. So I told him, I'm sorry, you know, it was a great try. You gave it your best shot. And then somewhere in June or July, I got this message that your student has won, and he has designated your site for the $10,000 grant to make a makerspace, which we have been equipping and building ever since. So it's been quite a ride, and it's just a lot of fun.
That's awesome. And you've had a really good spirit. You've been to several of our professional developments, and you have acquired a lot of skills doing this. I think all the people who are watching would be interested in knowing that you have a laser cutter up and running. So you have a laser, and you're using this with elementary kids.
Correct. So there's a key word in what you just said, Ken, and that is acquiring.
Acquiring.
I have no background in coding or electronics or even being a handyman. I'm not any of those things. I'm very good at teaching literature. I'm very good at grammar and spelling. But I have such a deep belief that our kids deserve this, and that this is the future, and that there shouldn't be those who know and those who don't know, and there shouldn't be any limitations on the children of today having access to the world of tomorrow. So I'll jump in and try anything, and I will figure it out. So the laser cutter was purchased at my insistence by a principal who's no longer here, but was very supportive. And I struggled to get it working and figure it out. But this year we had a couple of our instructional aides who were just really interested, and they had felt left out before, and I didn't know that. Once we roped them in, one of them is just running with it. And now we're cutting mostly cardboard and wood, but we're engraving different kinds of plaques, all different kinds of woods. We've done metal, we've done some cardboard again. We're working on plastic and glass. So we have several projects that I'm able to build into my English classroom that will involve the laser cutter.
It's awesome. And you also were the San Juan Unified School District Teacher of the Year. Just have to throw that in.
Thank you. But let me comment that the lesson they observed was all about robotics.
Oh, okay. The next person I'd like to introduce you to is Wayne Greene. And I got to meet Wayne in person finally last year at the USA Science Engineering Festival. And he helped me run a booth that was totally overrun with kids. And we were just overwhelmed, but he jumped in, which is just like his style. He's hands-on. And Wayne is the founder of the Coastal Georgia Radio Science Academy. It's a nonprofit, Christ-centered STEM after-school program in Brunswick, Georgia. And Wayne has an interesting background, which he might share. And at the moment, he's actually in front of a class. His students, if you turn around his computer, we'd see a bunch of kids programming robots. See? For real. So we got a little class tonight. So, Wayne, tell us about yourself, please.
Hi, so my name is Wayne Greene. Brunswick, Georgia, if you're not familiar, is about halfway between Savannah, Georgia, and Jacksonville, Florida. We're just off the Interstate 95, right on the coast of Georgia. So we were a little bit worried about Florence for a short time, and then she decided to go north. We ended up having some evacuees from Charleston in our house, which was great because it's the first time in 2 years that we weren't the evacuees. But hurricane season's not over yet, so we'll keep praying that it stays that way. But so by trade, I am I've worked in electronics all of my career. I'm in federal law enforcement. I do covert electronics, or did anyway. I now teach, but I did covert electronics in support of criminal investigations for 20 some odd years. And now I'm down here in Georgia, in Brunswick, Georgia, is the Federal Law Enforcement Training Center. A lot of your federal agencies come down here and do their basic and advanced training here, and I teach electronics and covert skills here. So how we got started with this little organization we've got now is we homeschool our kids. We belong to a couple of different homeschool associations, and they do put together classes for the kids. And I noticed there wasn't anything much in the way of STEM So I told my wife, who was on the board, that I could put something together and be just a simple little electronics class. We did that 4 years ago. And frankly, this thing has turned out to be something bigger than we anticipated. This class is our smallest class. You see that there's 3 students. One's actually missing tonight. So we actually have 4 in this class. But I've had as many as 25 in other classes. We are doing 5 classes a week, 2 on Tuesday nights. This is our second for tonight. 2 on Thursday nights and 1 on Saturday mornings. We teach using the Bobots. That's what the students are working with tonight. Bobots, and of course the basic stamp microcontrollers, the propeller flip, and this year we brought in the microbit. This is that's the Saturday morning class that we run. What else? What else do you want to know? I feel like I've talked way too much. So,
Great.
Yeah. One thing that was mentioned by Theresa, that not having the background, that, she's a real good literature teacher. This coding thing, I've mentioned this to Ken. I worked in electronics all of my career and a little bit of coding, but nowhere near what we're doing now. So I'm teaching myself right before I teach the kids. So frankly, I'm having as much fun as they are. So
Yeah.
Now I'll be quiet.
It's perfect. Thank you, Wayne.
Yep.
Next, I'd like to introduce John Agostinelli. And John is what we call a CTE teacher in California, Career Technology Education.
No.
And it's a fairly newer type of credential that is very focused on the trades. And John has touched nearly every single trade in school. I'll let him tell us about what he does because it's interesting. And he's at Ike Middle School in Roseville, California. John?
Thank you. It's nice to meet everyone. So we run a pretty big CTE program. It's been growing each year, and we have 6 completely full classes of it, and we had more demand than we even had room for. And so we run a couple different classes. We have a wood shop, we have an engineering and fabrication class, a cabinetry and construction, and then an electricity, electronics, and robotics class. And that's where I got my introduction into the robots. And so funny thing for me is I've been teaching for about 15 years, and Parallax was kind of my first intro into electronics. I got my intro probably about 18 years ago at American River College. They were teaching robotics, and they were using Parallax stuff to teach everyone how it worked. And that's where I got my start. And then when I started teaching, I loved it so much. Everyone loves robotics, so they just let you do whatever you want if you mention robotics. So I just said, hey, let's do a robotics program, and we started it up. And I didn't really know totally what I was doing, but I jumped in with the Bobot way back then. And so in a way, Andy Lindsay, who wrote that book, basically did a lot of my robotics teaching because it kind of guides you through. And I've had a very good time teaching the robotics. And the robotics are so fun in a lot of senses. The kids will come in and they're so focused on the robots. It's like, hurry up, take roll, let's get going. And I had teachers walk in before and they're like, how do you do this with the kids? And I'm like, I didn't do anything. They just love it so much. And so it's one of my favorite classes to teach because once you figure it out, it's just like the kids run it themselves because they're so into it. And I haven't seen too many other classrooms like that.
And some of the trades you've taught include construction, welding, wood shop, metal shop, auto shop, fabrication, electronics, and of course robotics.
Yep, big fan of CTE. It's always supported me throughout my life, and I think it's just getting more and more powerful, and it's becoming a very, very good alternative for kids to get a career out of.
And this year you're running, really a huge program. If you can talk about the scale of it, you put through how many kids? Is it like 3 or 4 periods?
No, we probably 100, and my limit, I think, by the state is 180 kids a day or something, and that's how many we put through.
Wow. That's middle school, John?
That's middle school, yeah. And it was so popular that I could have run 2 complete engineering classes of just girls.
Nice. Wow.
So it's something that kids really crave and love, and it was always my favorite class in school was the shops. I just loved being able to put my hands on a tool and do something with it. Like, it makes you bigger than what a human's capable of, and I always thought that was magical. And so I'm glad to be able to pass that on to the next generation.
Yeah, John, I would echo what you said about growing up with tools, and that's what gave me all the interests I have today, for certain. So let's jump right in. Our first question for you is about these different teaching approaches. So these are probably pretty common words to all of you, and you probably go to seminars to talk about them. We discuss them inside Parallax as outsiders and read about them using Google. But of course, we know all about the robots and all the technical stuff. So we're interested in hearing from you about how you apply these big words, cross-curricular learning, STEAM, where you combine art, technology, math, science, project-based learning, computational thinking, and place-based learning. So maybe you can each choose an example. I could start, by sharing a project I'm working on. This is my visual metronome. So this would be my STEAM project. And although it is not a robot, it does not have wheels, it uses all the same things as a robot does, electronics and programming. And behind me off the back, you'll see a big robotic boat that is used to explore the lakes in our area that some high school kids will be programming. So that's about as much as I know about it. So I'm interested to know if you could each provide an example of how you do this. Maybe Theresa, you want to share one?
Sure. If I focus on the area of robotics, as a teacher of writing, students are more engaged and more interested if they're writing about a genuine experience. Well, what could be more genuine than your experience with robotics? So anything I do, whether it's just having students program a robot through a maze, or last year we did delivering messages from class to class using robotic messengers. It's engaging for them, and the writing that I get afterwards is very, very powerful. Even the students who feel that it's over their head, they watch me, they know it's over my head. They know I was not raised with tools. I was not an expert coder. I can write. And so they watch me and they realize that there's just no holding back. Just jump in and try it, learn from your mistakes, figure it out, and then go write about it afterwards. And people are amazed at the quantity of writing that students will produce and the engagement they have with it when they're writing about that sort of experience. So this year they've been writing stories about their own lives so far, and we're hoping to have our scribblers with a dowel and a clip, and we're going to have a robot parade and deliver their stories kind of in a parade format past the office. So it really is the definition of cross-curricular.
So you're tying it directly into English and writing then?
Correct. I'm the English teacher, so that's my call.
Yeah, that's the first time I've actually heard a teacher doing that in that way, but it makes so much sense because I remember writing so many papers where the topic was not interesting or
Right.
was kind of forced, but when it's open like that and there's something physical, you could tell a story, right?
Right. And when you think of writing, I'll speak to John for a minute, because as a CTE instructor, he knows that a lot of what people do is somehow communicate in writing, or that, reading, they have to read the directions, or they have to problem solve together with some sort of plan. And pretty much whatever you're doing around the trades is going to involve some form of writing, even if it's just texting and communicating. And the more powerful that can be, the more effective your work can be as a collaborative team. So I just see it as the underpinnings of everything that's really interesting.
Yeah, it's fascinating. I mean, sometimes I do say that we have lots of coders. We need people that can communicate what they're doing,
Right.
communicate the products we design and communicate them to other people so they could use them. That's a big part of doing anything. So we value what you're teaching, and we want employees that can write well. They can write a simple email and can write instructions or documentation.
Right.
So keep doing it.
Thank you.
Wayne, what are you doing?
Sorry, I had to unmute the mic. I started to talk without unmuting the microphone. So yeah, these are big words here, cross-curricular and such. So as I mentioned, I'm not a teacher by trade, so I guess to some degree I'm kind of making this up as I go. What I understand most is project-based, I guess. I give the students a final project, For the robots, for the intro to robots, the final project is the ability to be able to program and run the maze. But for my intro to microcontrollers, I'm using the propeller, the flip. I was showing this to Ken a while ago. Our final project here is a kind of a calculator. The flip communicates with the computer. You have 3 push buttons. The 3 push buttons identify what math operation that you want to use, whether that be addition, subtraction, or multiplication. The computer asks you questions that you selected subtraction. Is this correct? You have to say yes or no. Then it asks you for your numbers you want to work. You'll see there's an LED here. The LED comes on as soon as you hit a button to let you know the operation is starting. And it stays on once the operation is done, and it does the math, and the LED starts to flash the number of times, whatever the answer is. You have the piezo buzzer there, and it gives you a 3-note tune, a 3-note tune, yes. Kind of just like this operation is ended and it starts over. So the point is, when on the first night, I show the students this. I show them how it operates. And they get to play around with it a little bit on my computer so they can see how it operates. For the entire semester beyond that, then each step we talk about, what's going on. This past week, we worked with getting the flip to communicate with the computer. So the project we used there was to build a bio, and so to come up on the computer, a little bit about you, your family members, what your favorite food is, and such. We're going to move into variables where that bio will change into a Mad Lib, and the kids will have to talk to each other and give a noun, get a whatever, and work the Mad Lib out. And then we get into the LED. So you see where this is going. So for me, this is more project based, but I can understand that it hits some of the other points as well. I would like to say that I really know what I'm doing, but I'm just kind of figuring it out. And the one thing that I did notice from a couple of semesters ago is the push button circuit. That pull the ground circuit seemed to kind of be lost on some of the kids. So we spend time like 2 weeks just dealing with that push button circuit, so that when they do the calculator at the end of the semester, it's not that difficult for them. They've seen it before.
And Wayne, you and I have talked once before and discussed how we could use LEDs and push buttons for a whole series of courses, really.
Right.
There's so much there with logic and input, output, and program structuring.
And we also get into the basic electronics as well. We kind of gear things, the idea is that in later semester we kind of gear things toward wireless technologies, which is, the reason why we call ourselves radio science. I thought that was a term I made up on my own. I thought it was really cool, but it turns out that's everywhere. So yeah, I still think I'm cool, but we call it radio science.
So question how you manage the project-based learning. You have that calculator and you show it to them in the beginning.
Yes. And
the goal is they will all create one.
Right.
How much accompaniment do you provide them to take all the steps to get a working calculator? Do you progress at the same rate, or do you send them to tutorials? Or do you walk away and go out for coffee and come back?
No, each week there's it's a 10-week program. So each week we take a particular approach. So this last week, as I mentioned, we talked about the communication between the microcontroller and the computer using the terminal commands with the Blockly, right? This Thursday, we start getting into turning on and off and flashing LEDs, and how to make a pin high, how to make it low. We talk about the pause commands, and we're just getting this. It's kind of the foundation stuff. Getting the LEDs to come on, getting them to turn off, getting them to flash, and also getting the microcontroller to communicate with the computer, and vice versa. The third week is actually when we get into Ohm's law, and we're only going to just deal with the math of Ohm's law. We talk about the schematic diagrams, because when we get to the end, that final project, the last night, that 10th week, is just the students sitting down and building the project and writing the code. And what I teach is start with a schematic diagram, draw it out, know which pin is going to be connected to what. So they get taught that on the third week. They learn about the math behind the Ohm's law, so that they know a little bit about what's going on, what's happening with the current, your voltage, your resistance, all of that. But each week we take a different piece and put it together. And each week has its own little final project, if you will. But it all comes together at that last week to where they think on their own. That's the other thing. I want the students to be able to use some critical thinking skills and to think on their own on how to put this together. We don't build the calculator in pieces each week. We talk about the concepts, and then they have to put the concepts together at the end of the week in order to do the calculator. I'm hoping I answered your question.
Yeah, it's perfect. And one thing I'd like to draw attention to as well is that you build these projects in small steps. So this is a tip we can give all of you middle school teachers, which is have your students do things in little steps and make the little pieces work and then move on to the next one. So one thing at a time, because so often they'll jump in with enthusiasm like my color-coded line follower and build the whole thing and then slam a bunch of code together. Nothing works, but it's the same tip that would apply to embedded or physical computing product developers. Work in little steps and make things work one piece at a time. And then you don't really get frustrated and your success is higher. And well, I think you know that. Yeah. So
Absolutely, yeah.
John, what kinds of things are you doing? How are you applying all these teaching approaches with robotics?
Well, I'm a big fan of just jumping in and screwing stuff up till something goes right. And I was going to say with a lot of this cross-curricular stuff, you don't even need to plan. It just kind of will happen. So one of the funny things we had this year is the science teachers always do solar ovens. Okay, that's one of their science projects. Well, for us in the electronics class, we worry about energy efficiency and insulation. And so when we were doing that, we were using infrared cameras and talking about insulation, how it keeps all the energy in. And so the kids were building these solar ovens just after they had my class with the infrared camera. And so they came back to my class to get the infrared camera and then realized their solar oven was super inefficient, that it was bleeding out all of this heat everywhere. And so they decided they wanted to insulate it. And then their solar oven was so much better than everyone else's because of that. And so it's just like, without even any attempt on my part, I never even would have thought of that. They just, like the kids found it on their own, and because something they learned in my class helped them with another class. And so it became cross-curricular real quick without even any planning.
What you just said is something Kate and I discussed yesterday. We're talking about how these approaches are applied, and it just happens naturally, it feels like. Is it that way, Theresa?
Absolutely. Absolutely. And oftentimes it's the kids who stimulate it, just like John was saying. They come in with an idea, can we do this, can we do that? I had a strong push last year for, they wanted to build a robotic arm. Well, where do I start with that? So of course I go to YouTube and figure something out, and go to Parallax for parts and just figure out what that's all driven by the kids' interests, and it just, how far can you go with that? And you run with what they want to do, and it just stimulates the learning to the point where it's like out of control. It's exponential, and you didn't even plan a bit of it.
Wow. Well, we really want to encourage that kind of thinking, because you're showing them how to learn and letting them do it. And this is the way education is working. It works for us that way at Parallax. Mm-hmm. We have to go learn on our own on the web, and it's very effective. Mm-hmm. I think we handle students in that way, and I think they're so turned on to have some control over the situation, and not just being spoken to, but actually being the driver of the project. Wow. Kate, do you have any questions here?
Actually, I wanted to find out, do your administrators or your schools, do they also, do they come in and say, use these terms and ask you about how you're teaching with these terms, or no? Are they like, hey, you're doing robotics or you're doing STEM and it's all good? Is there kind of burnout when you have to do cross-curricular learning, or now you have to do STEAM? do they press you on it? I guess that's what I want to know.
For me, I could answer that. We have been designated as a STEAM site.
Mm-hmm.
And in the early stages of that, it's building our makerspace, understanding what, micro units and tools and supplies that we need, and then generating teacher interest. So if somebody walks in and the kids are engaged, and I'm addressing some of my main standards with that, and I'm wrapping it all around a project that they have to produce, or some specific, technology piece that they're learning, it's just everyone's happy and asking, can you share that with more people? And how can we support you doing that? And how can we do more of that? Like we're collective in our thinking that this is the way to go, and that we need to support and teach teachers like me who don't have, John and Wayne's knowledge. How do we get there? And so we're just all in it together.
Great. That's really cool. And John, with the CTE, so your courses that you're teaching are CTE. Is there a certain pathway that you need to follow for your courses?
CTE is a fantastically written set of standards. It's not like the history one where you have one little tiny thing that becomes a standard. CTE is very wide open. It's very broad. And so it's just concepts that you have to cover. Mm-hmm. So we are under the construction pathway, yet we still do all kinds of engineering, construction, or fabrication, electronics, and robotics. And so they're very broad. And truthfully, in the classroom, you probably get bugged in these fields less than any other one. We tell the principals, oh yeah, we're working on microfarads today. And they're like, oh, whatever. It's just leave you alone. So you get tons of freedom on these programs, and they're always popular. So my experience is nobody ever pushes you on anything in these, and they love all the stuff that you do. And the STEAM is just extraordinarily fun and exciting, so we do it all naturally. But I would say we never, ever get pushed. They love our programs. They never,
Great.
They basically leave you alone. They don't know what you're doing, but they love what they're seeing.
That's great. That's very good. And then for the kids, I've always wondered, for your students that take a keen interest in that, they're all about the robotics and the programming, how do you challenge? Do you give them special challenges, or is there any creative way to keep their learning going on a path that maybe it's not everybody, the general population?
Oh, yeah, that's one of the strengths of doing the robotics like this, because we run them through, actually, I copied their original Bobot book. Like, we do the same thing they do. We do the programming sounds, to get the LEDs to blink, to running the courses. Hey, now we need your robot to not just run over somebody, but to see them before it runs over them and turn away. And so we run them through all these different courses, make them have blinking LEDs like a turn signal. And so we have them do these courses. But the kids that are fast and get the stuff quick, they can add all kinds of extra features to it. Theirs can cut corners quicker, or move faster, or do a more smooth turn. So there's so much built-in higher level learning in it that the kids that are fast could do it, can put more time and effort into it. Or you could even just add, like, hey, you have to pick up this thing on the way. Or so it's really easy with the robots, probably easier than any of my other classes, I think, to do that.
Great. That's cool. Yeah, no, there's always those students that get very excited. In a lot of other classes, they might just sit around and be bored, or they might have to mentor their students, which is great, because they get to relearn the materials, but it would also be lovely for them to be able to challenge themselves. So yeah, robotics is key on that, and very natural.
I kind of handle that in a similar way to John, that mostly the students have a choice in terms of whether they partner up, group up, or work alone. But ultimately, there's someone who's just sort of nailed a certain area, and they sort of become an expert for anyone who wants to consult them at their expert booths. That's kind of they travel around to different expert booths in the classroom. So I also am fortunate enough to be able to run an after-school robotics club. And so the people who are just really geared into that will join the club. Although this year it's morphed, because the kids said that's not enough. We don't want to just do robotics. We want to actually call it coding and robotics and making. So we want to do all those things in our okay, that's how it's going to be this year. So we're just accepting applications right now for the club.
Kid driven, student driven, nice.
Yeah.
I also have my preliminary CTE credential.
I want one.
What I totally lack is the teaching experience, but I have the industry experience. So I have it in engineering, architecture, manufacturing, product development, and then marketing, sales, and service. And I've used it for about 7 years, which brings us to the next question I'd like to ask you. So in my experience as a CTE teacher in our local school, I really suffered under my own enthusiasm, which is tons of machines, tons of I had laser cutters, 3D printers, CNC routers, robots, anything else we pretty much have in our school system. And we have trouble getting teachers we have trouble actually hiring teachers where we live, and the turnover is quite high. So we haven't been able to get all these tools to be used in concert, but my problem certainly was being overwhelmed with all the opportunities and the ideas, and then structuring them in the right way. So I don't know teaching, but I know the machine. So I'm curious, what advice would you give to new STEM teachers now that you've been doing this for a while? And it can be about electronics and robotics or not. But how do you get started without having a lot of know-how about this? And anybody is welcome to answer.
Okay.
Yeah.
I seem to do a lot of the talking. I think you just have to be really willing to fail, and you have to be willing to try it out, and you have to be willing to learn from your failures, and you have to model that for kids, and you have to just jump in, express your ignorance, but your willingness. It helps if you have community volunteers, if you have parents, if you have anyone, but I really haven't. I mean, I've latched on to a couple of people who've been really, really helpful, but it's very slow. It's very slow progress. I attend every professional development training that I can find. And when I talk to other teachers about it, they'll say, oh, my son's doing this or my grandson's doing this. And I'm like, good, have him teach you, because you can learn from anyone. It doesn't matter. Spread the wealth and be willing to be a learner. And if you're committed to that and you understand that the kids deserve this, and so you have to go there, then I think you will. And it'll take you there, and you will find some avenue that works for you, whether it's your grandson teaching you, whether it's that Saturday training that you put yourself out there for, whatever it is. It's about your attitude and embracing what's best for kids for the future.
So you have to be open, somewhat vulnerable, and then bring in expertise when you see it.
Yeah, that sums it up.
Great. And Vicki, one of our attendees, has her hand up. She may have a question. Vicki, is there something you wanted to ask?
Hi. I love the online resources that you have with under the learnparallax.com. I wondered if there was in the works or some other resource that you have that tells the students a story or the why someone might do any of these things. So I'm always looking to get kids linked in, and I am a creator of my own storyline, like I'm sure we all are, but I am also certain that there are better stories than I am creating, being just a teacher in the classroom. So what else? Is there anything else that is available that I can, do you understand my question? Does that make sense?
Yeah, like why are we doing this?
Yes, the why. Not just the how, but the why.
Yeah, why are we doing it? And so I think there are a lot of, maybe Stephanie will have some ideas there too, but I think it does boil down sometimes to personal interests and what kinds of careers people are interested in exploring. So I try to relate everything, and this is easy for us to do because we're in this industry, not in the classroom, but when you take a microcontroller, we can talk about it with all kinds of real world applications where they are used, and how something small can also control something big, a large robot or manufacturing type machines. So we try to relate it to other things they're familiar with, or maybe use place-based learning. So what locally, in your environment where you educate and live, are applications of this type of thing. That might help. Or bring in engineers who work with the tools too, and have them talk about it if that's of interest. Stephanie?
I think you pretty much covered what I was going to cover. On some of our C tutorials where there were fewer images, C for the propeller, we would have little areas on some of the lessons that related the circuit being used or the physical principle of that sensor to a larger application you might see in industry or a commercial or some type of equipment in a grown-up job setting. But I think the place-based aspect is going to be the best bet. There was a time when we were offering multi-day educators courses for credit through Fresno Pacific University, and the homework at that time was to develop place-based tie-ins to the lessons that were specific to the industry in the area that the teacher was getting the students prepared to enter that workforce.
Vicki, we're trying to produce more projects with what you asked for in mind. So if you look on Learn and then you go to the projects, you'll find some examples of real-world things that can get them thinking a little more. So that would be helpful too.
Ken, I think if I could just for a minute, since I'm also the history teacher and dedicated to social justice in a very broad sense, I feel that identifying the real world application is key, because if we don't have students who understand how the things work that they own, they have no comprehension of the world around them other than as a consumer. So when we have students who understand, that's a simple electrical circuit that runs that, or this is a microcontroller that does that, or what is a servo motor, and all of a sudden they can speak the language and have that inkling into, I can really pull this apart and understand what the parts are and how they work. They move beyond being a consumer to being in more control of their environment. And I think that's something, it's not just a gift we give children anymore, it's a necessity for their future.
Yeah, it's absolutely true. Do you want to be a user of the app or the creators of the app? Someone who plays the video games or someone who writes them? I don't know, questions like that might be a bit much for someone young, but that's what I would say to my high school kid.
Yeah.
Yeah, great question. So John and Wayne, what do you do? How do you suggest others get started easily?
I really like what Theresa said a while ago. It really is about, I guess, just jumping in and do it, and knowing that you're going to get it wrong in places, and not being afraid of doing that. I see the other part of that too is not only should you be afraid of should you not be afraid of getting something wrong, we should also be teaching the students that it's also okay to fail. Matter of fact, some of my best lessons are, through failures. I tell people I've got a master's degree in the School of Hard Knocks. But I see the students here, they'll do something that's not wrong, they'll get upset about it, and I kind of explain to them, so, okay, so now we know that didn't work, let's talk about what might work. And through that process, it helps them build even more self-confidence in what they're doing. My background has always been electronics. It's been in radio type electronics, but this stuff that we're doing now, I didn't have any background with this at all, but it's just, I wasn't afraid to jump in and do it. And it's been thrilling so far. And I'm having the greatest time ever. And soon I'll hopefully be able to do this somewhat full time. But really, I think Theresa absolutely nailed it. I can't think of a better way to answer that question whatsoever. That was awesome.
John?
Well, I'll tell you, the way I did it at first was I just had that Bobot book, and I stayed a week or two ahead of the kids, and it laid it all out for me, and I learned that way. But the other thing I was going to say is you just we want kids to fail, like over and over and over again. I always say you're going to fail so much in this class that you won't even think twice about it. And so when you think it's crazy, like, oh, I got to learn all this stuff to help these kids, you actually don't need to learn quite as much as you think, because you can just, like, you'll ask a kid will get his robot all ready to go and want to show you, okay, it's ready to run the course. And I'm like, okay, well, let me see it. I'm going to start it all official, and then I'll pull like a little resistor out of it or something and not tell them, and I'll put it down and hit start, and it won't work. I'll be like, you just told me this thing was all ready to go. And then all of a sudden they have to figure out why it's not working. Well, there you just added a lot of time to them. They're learning a really valuable skill, like how to diagnose that. And, it's like, so you can mess with things and things that you think are simple, like just say stripping the end of a wire. Kids don't know anything. They don't know any of that stuff, how to use a screwdriver, all this stuff. So you can add in all these little things that are so basic and so easy, and you can really start that way. So like, don't be so scared of it, because you can add in a lot of things that you didn't even think. You know, some of the steps in the robot book, like how to wire it and all that, like a kid might not know what a needle nose pliers is, and that could help him put wires together. Or you can just once he's built something, you can lay out the schematic. Hey, you need to wire it to this specific pin now. And so you take what that basic little bit of learning that you know and just change it all around a bunch, and it's a whole bunch of lessons all of a sudden.
So a comment about something I'm hearing from all of you, and you teach middle school as a reminder. In the past, and we've been making robots for 20 years at Parallax. We've made a lot of robots, especially the Bobots. It was normally high school on up and community college and college using what you are using. And we have seen the capability increase tremendously at lower ages. It's just going up. I mean, and I think like Theresa first learned on the Scribbler, and then I think she wound up in an activity bot class with electronics. And we're seeing a lot of this happen because student capabilities is so much higher. But to your point, yeah, good things are failed first, right? And then you have to make them work. So there's a lot in a project like this. You have electronics, programming, sensor placement, breadboards, power supplies. There's a lot to go wrong, but that's reality of engineering in life. It really is. You have to make things work from nothing. So I really back what you're saying. And is it true this is probably the first experience they really get in middle school to really truly fail, like intentionally before you win?
Yes.
It is?
Kids are horrible at failure, absolutely horrible at it. They can't take it very well. They don't know how to move beyond it. It's like devastating. It's like failure is one of their most important lessons I think they get out of my class is just jump in and try it. And they always want, well, how do I do it? I don't know. Try something. And yeah, to me, failure is really, really important, and we don't teach it in schools. We're the caretakers of that in CTE. We teach that stuff. So yeah, it's like our sacred mission to help them fail.
I would agree with that 100%, and I feel like that's one of the things that has been ingrained in them in the K-5, K-6 system, that failure should never happen, and it's embarrassing. You need to be in compliance. And we work in middle school at reversing that.
Yeah, it's unfortunate. I still, with my high schoolers, I'm so focused on grades with my own children. I don't really know why. I think it's just from my own past education. You have to get good grades so you can do this and that and that. But it's such a demotivator sometimes.
Yeah, it is.
So I'd like to ask any of our attendees if they have any questions for our panelists. You can type them, or you can just raise your hand and we can allow you to talk.
We had one question in the chat window about how many robots per student and how you manage that with a group of kids on one robot, or do you change it up?
So I don't know if I have time to tell this story, but I started off with some of those little toy robots that started flooding the markets a few years ago, and then moved into I've had, I think, 6 different levels. Ken, we're still at the scribbler level. I always struggle with that one. For our 7th graders, but our goal year by year is to push those down into the lower grades still and bring in the activity bots over time. But in the beginning, I had 34 kids in one robot. And it just depends on the robot. The joy of the Scribbler, unlike all the other ones I've tried, is that you can have kids on your Chromebooks and they're programming, and they can each download their own program over time and test it. So it works better than a situation where you have to have one device per the robot and you can't download it and you have to be connected. And so some of it is the experience in understanding which type of robot will fit whatever robot to student ratio you have.
Interesting, yeah. And well, can I ask a follow-up question? How do you, since you've used a variety of different robots and different tools, how do you determine their effectiveness, or, is it just kind of gauging the student's interest, or how do you know that it's working, or whatever, reaching your goals as a teacher?
Right. So you have to have those goals set first. And one of my very first goals was, this is not going to be a toy. This is not going to be a remote control thing that you just play with. And I needed to move the kids beyond that into even understanding the concept of downloading a program and having this tool. And I think whoever it was said, maybe it was John, said that, the tool allows you to do things as a human that would be beyond you. And so understanding that that's really what we're talking about, rather than just, hey, it's fun, look at it, look what I can do. And they've got their little device. And so it's taken, I'm going to say 4 years for me to progress in my knowledge to understand that right now, for me, the scribbler in my classroom is what gets that point across to the kids most clearly.
Mm-hmm.
And yet is still at their level and not so intimidating that they can't find a use for it and find an application for it. I mean, the ability of it to write and to carry things, that's just fundamental to that understanding of the kids that this is here for a purpose. And I can control that purpose, and I can make it do something that's useful.
Oh, yeah. Can I quote you on that? If that was John's original quote about a tool that's really powerful.
Vicki just made a comment that I've heard others talk about, including Stephanie. She has a scribbler balloon battle where they put a balloon on one side and a pin on the other, and they have to make a program that would pop the other kid's balloon and protect their own balloons.
I'm going to do that.
So there you go.
I love it.
Okay, videotape it and post it to Facebook, please. That's a good one.
All right, I'll do that. Yeah.
Any other questions from the attendees? You want to type or ask, feel free. I see a lot of important names out there, and even some engineers that contribute on our Facebook group and answer questions, which is great.
Yeah.
Okay, well, maybe we should move on and perhaps do something like this.
Ah, yes, we are giving away.
Wayne, Theresa, and John, we're always happy to send you any hardware you would like, and we have a gift coming your way. These robots are for any of our panelists, provided they have USA shipping destinations, and I think, or our attendees, I'm sorry. And I think Kate has already done a random.
Yeah, I pulled the list, and the names are Bridget Johnson, Marjorie Anderson, and John Soper. I hope I pronounced that correct. I see them on right now. So 3 people, we're going to ship you an ActivityBot 360, and we'll get that in the mail tomorrow. Actually, I'll have to email you because we don't have your address. So expect an email from us, and we'll get you set up.
And for our panelists, they are each receiving our new Badge WX. So they have an electronic badge to wear around their neck.